Yeah. So this is on page 18 of your booklet. So when we write chemical equations, okay, it is really important that the number of atoms on the left and the right side of the arrow is the same. And the word I really like to underline here is arrow. People will put an equal sign in their chemical equations because they think of math. Unfortunately, an equal sign will not cut it. You need to include an arrow. Okay? So this is done. We need the same on the left and the right in order to satisfy this thing known as the law of conservation of mass. Okay? We can't create things and we can't destroy things. Okay? It's like when your test is right in front of you, I bet you wish you could just create the answers right in front of you, or I bet you wish you could just destroy the paper and it goes missing and it's never found ever again. Unfortunately, we can't do that. Okay? We can only bring along new things. So we've got some examples, okay? And what we're going to do is we're going to do them step by step together. So we're going to look at sodium and chlorine together. So on your whiteboard in front of you right now, can I get you to erase, first of all, anything that you've been doing, like any dot paintings or anything like that? And then secondly, what we're going to do is we are together going to write sodium metal, or just sodium, plus, chlorine gas. We draw an arrow, and that arrow faces one way, and I end up with this stuff known as sodium chloride. So this is our first step. Now, this thing here, what we've just done, and what you're doing right now on your whiteboard, is what we affectionately refer to as a word equation. Now, I don't need you to write this on your whiteboard, but I just want to make it clear. So, first things first, this right here is a word equation. What we then do is we start in our next step by writing what we call the chemical equation. Okay? Now, the chemical equation is where we take each of these things and we turn it into the chemical symbols. So you need your periodic table in front of you. And when we look at sodium on the periodic table, you would see that sodium has the symbol of what? Na. So we write Na plus chlorine gas. Now I'm going to give you a helpful hint here. You see all of the halogens in group 7 of your periodic table? All of the group 7 elements, they like to exist with a friend. They get really lonely if they don't hang out with someone. And so chlorine gas, rather than just hanging out as chlorine, it hangs out with a friend. So Cl2. Okay. So if you read it as a gas, it's going to have a 2 there for those elements in group 7. Now, Na and Cl2 form something called sodium chloride. And yesterday we had a look at how we can write ionic formulae. And sodium is in which group of the periodic table? Group 1, so its charge will be +1. Chlorine is in group 7, meaning its charge will be -1. Do +1 and -1 balance? Yep. So we can just write NaCl. We'll get to it. There is no 2 in NaCl because Na is positive, Cl is minus. They cancel one another out. The Cl is just over on the left. We don't need it on the right now because it's all balanced. Okay. What we now need to do is we need to write a balanced.
Wait, what happens to the 2? Yeah, like the little 2.
So Cl is in a little 2 right now because it wants a friend, right? But chlorine, it's because it's a gas and it needs a friend to be stable. However, chlorine over here has actually found a new friend, okay? And now it's bound to sodium. So right now, if we were to have a look over on the left and the right, we would see, well, I've got 1 sodium on the left, and how many sodiums on the right? 1. But I have a look on the left and I see I have 2 chlorines and only 1 chlorine. So here's how I balance my equations, and here's how we're going to practice doing it as a class. Number 1, before we can balance everything, I'm going to write out the formula one more time, and I write it out as this, because this is the same set ratios of everything. These ratios can't change. But what can change is the number that we put out the front. Okay? So Your page looks like this. You've got a little bit of room down the bottom. Here's what we're going to do. I know you don't have different colours, but I'm going to use some just to make it very, very clear. Right now, I'm going to write in the middle of that arrow, I'm going to write sodium, Na, and below it I'm going to write chloride or chlorine. Are there any other elements involved in this equation? No. Okay. Now, when I look at sodium, how many sodiums do I have on the left-hand side? One. So I'm going to put a 1 over on the left. How many sodiums do I have on the right? One. So are they balanced right now? Yeah, life's good. Great. What about chlorine? I start on the left. How many chlorines do I have? 2. How many chlorines do I have on the right? 1. So we only have 1 chlorine in NaCl. Only 1. So my question to you is, I can't delete things from existence, but I can find another of something. So I can't delete a chlorine over on the left-hand side, but I can certainly find an extra sodium chloride. So what I do is if I find an extra sodium chloride, I already had 1, I find 1 more, how many sodium chlorides do I have altogether? 2. And so what I'm going to do is I'm going to put a really big 2 out the front of sodium chloride. What this does is it now means that over on the right-hand side, how many chlorines am I going to have, the thing that we were balancing? 2. So I can use my whiteboard, I can erase that, and I can write 2. Is that all happy now?
Wait, so does it mean that...
Question? Yeah?
Does it mean that there's 2 for both of them? Or just...
Correct, it does. And so what's happened is now, if we look at sodium, because it's all about double checking yourself here and constantly checking the answer. When we have a look at sodium chloride, we now see how many sodiums are on the left? 1. How many are on the right?
2.
Okay, so I'm going to use my whiteboard again and I'm going to erase that and write 2. Now, again, I can't delete anything from existence, but I can certainly go and find some more. So, what can I do for sodium to make sure that it is equal on both sides? What can I do? Great. I can go and find an extra sodium and I can write a big 2 out the front of this one here. And what that is going to mean for me is that now I have 2 sodium on both sides. So I'm going to double check everything. 2 Na on the left, 2 Na on the right. I then check chlorine. 2 chlorine on the left, 2 chlorine on the right. Is everything the same on the left and the right? Yes. Question. And then question.
Why is there not a little 2? Like, why does it get a big 2?
Good question. So when we did the chemical equation, this is how everything likes to exist naturally in the world. Okay? This is where everything is balanced. It's where chlorine's got its friend as a gas. It's where all the charges are balanced in our ionic formula. When we're balancing this, I can't magically turn this into NaCl2. If I turned it into NaCl2, it would turn into sodium dichloride, which is a different thing. Okay? And so what we do is we can only change the amount of these things. So it's like a big ratio. It's like baking a cake and saying, okay, I've got 1 part flour to 2 parts sugar. Great cake. Okay? I can't magically change the flour though and use corn flour instead. That would change the recipe. That would change things. Okay? We had a question here first. Yeah.
Oh, it's going to come in here.
Yeah.
Wait, so does it have to be the same? You see how they're all 2s right now? Does it, they all have to be 2? Can, like,
It could be all 3. It could be 10.
Can like Na be 1 and Cl be 2? But
Yeah.
they both be 1 and both be 2?
Exactly right.
Be like 2, 2.
No, as long as we have the same amount on both sides of that one element, we're happy. Okay? So I could have had 6 sodium on both sides and only 1 chlorine on both sides. As long as that's everything is even on both sides, we're happy. Okay? Last question. Yep.
So can you not use little numbers in balancing equations?
No. So great point. When we're balancing chemical equations, the only number that we can change is this big number out the front. Okay? That's the only number that we're playing with when we're balancing. So let's do another example. Okay, let's do another example. And our next example is aluminium and oxygen gas. So, can I get you to erase what you've done so far on your whiteboard? Let's go through together. What? I'll do water as an example a bit later on. Okay, so aluminium. All right, here we go. So, on your page right now, what have I just written up the top? What kind of equation do we call this one? This is the word equation. Why? Because it's a whole bunch of words. Can I get us to close laptops and make sure we're following along, please? So, when we're talking about this word equation, we then use our periodic table to turn it into a chemical equation, not a balanced one. We're not worried about balancing, we're just worried about the chemicals. So right now, if you were to go and find element number 13 on your periodic table, you would find aluminium, and the symbol for aluminium is Al. And right now we've just got aluminium metal all by itself. Oxygen. If you were to look for number 8 on your periodic table, you'd find oxygen. Oxygen symbol is O, but oxygen is a gas. So what is oxygen going to want to exist as? O2, okay? O2. And here's the skill that we were working on in our prior lesson again. What charge does aluminium have? It's in group 5, so what charge does it have? +3, okay. And what charge does oxygen normally have? -2. So what's the lowest common multiple between these two? 6. So how many aluminiums do I need to make sure that the charge is equal to 6? 2. So Al2. How many oxygens do I need to make sure that it is equal to 6? So oxygen is -2. How many lots of oxygen do I need to make that equal to -6? 3. So O3. And this one right here, right now, is our ratio for aluminium oxide. It's how aluminium oxide likes to exist. Question? Sure.
Wouldn't it be O2 in the bracket?
No, because it's just one element. If we were doing a polyatomic compound, then it would be a bracket, you're right. But for this one, because it's just oxygen, no bracket.
Okay, and then why are we supposed to just know the oxygen gas and like all the gas?
If it says gas, just put a 2 next to it.
Okay.
Yeah, it wants to hang out with a friend. Okay, so what we're going to do now is we need to balance this. And again, I want to see people, I'm going to wander around the room as we're doing this one. I want to see it. I want to see you writing the elements below that arrow in a line. So how many different elements do we have in this scenario? 2. So I'm going to start, and again, I'm going to use a different color. I'm going to write aluminium first, and then below it, I'm going to write oxygen. So over on the left-hand side, how many aluminiums do I have? 1. Okay, I want to see everyone following along with this right now. We have 1 aluminium. Over on the right-hand side, how many aluminiums do we have? 2. So we write on the right of aluminium 2. When it comes to oxygens, how many oxygens do I have on the left? 2. And how many oxygens do I have on the right? 3.
2.
Now, we are going to start with our aluminium once again. And I'll give you some rules in a minute to help you out. But for now, we're just going to start with how we've written them. So aluminium. When we start with aluminium, how do I balance aluminium? What do I need to do? I need to double one of them. Which one do I double? The first one, the one on the left. And so what I do to double that is I write a big 2 out the front. And what that does is it changes the number of aluminium so that I've got 2 and 2. I'll be happy with aluminium now. Yeah? Next, we need to look at oxygen. Now, oxygen, it's got 2 and 3. What might we need to think about with oxygen in order to make sure that they're balanced? Because if I just add an extra oxygen, an extra O2 here, I'll end up with 4 and 3. Okay? So what could I do instead in order to make things lowest common factor, lowest common multiple, okay? And so what we're going to look at here is if I double the number of aluminium oxide on this side, it gives me how many oxygens? 6. So, to be really clear, 2 lots of everything here. 2 lots. So 2 lots of 3 oxygens is 6. 3 oxygens, and I've now got 2 of everything. Okay, so 6 altogether.
So do we need to change the aluminium?
Yes, it will in a minute. We then look at oxygen. If I've got O2 here, how many O2s do I need in order to equal the same on the other side? 3. And so what I do is I write a big 3 out the front. So now I'm really happy my oxygens are sorted. But what's not sorted now is I've gone back and I've had a look at aluminium, and aluminium is now equal to 4 because of 2 times 2. So what do I need to do over on the left-hand side? How many aluminiums do I need?
4.
Change it to 4. So I erase it and I write a big 4. And what this means for us is now on both the left and the right-hand side of the arrow, we have the same number of each element. So this becomes really important for us later on down the track in chemistry to make sure that everything is balanced. Okay? So what we're going to be working on and what I want to see when we're working through these examples are the following key things. Number 1, I want to see you start by writing out the word equation. I then want to see you convert it into a regular chemical equation. And then you're going to balance it. And I do want to see you using your whiteboards, and I do want to see you using them to re-evaluate, to erase. And only once you have an answer which is completely balanced, that is when you write it into your booklet. Okay? Writing into your booklet is the last possible step. So here's what you're going to do right now. Okay? We have the final rules. Okay? We always, okay, go in the following order. You are going to start with the element. Okay? So in our last example, the element was aluminium. Secondly, you're going to balance hydrogen. Okay? And the third and final element that you're going to balance is oxygen. So when you're writing down your page and you're looking at this like sodium oxide next, okay, I want to see you going elements. So the element in this case would be sodium. I then want to see you balance the hydrogens. And lastly, I want to see you balance the oxygens. So how confident are we feeling? Do we want to do one more example together? You know what, let's do one more together. If you're feeling confident, you can jump right ahead. So we're going to do sodium oxide and water. So let's do it together. I'm going to write it again over here just so we've got a bit more space. So sodium oxide plus water produces sodium hydroxide. And what was the final component? Oxygen gas. Hi.
The order was element, oxygen, hydrogen.
Correct. Element, oxygen, hydrogen. So what we're going to do now is we're going to write, first of all, the elements. So the first element is sodium. Next is oxygen. Last is hydrogen. So, question. Sure. So, when we talk sodium at the very start, how many sodiums do I have on the left-hand side? 2. So I'm going to write a 2 over on the left. How many sodiums do I have on the right-hand side? 1. I only have 1 sodium here. Secondly, oxygen. How many oxygens do I have on the left-hand side altogether? I have 3. So I have 2 in sodium oxide and I have 1 in water. So I have 3 oxygens. When I get to the right-hand side, how many oxygens do I have? 3. Excellent. And then when we talk about hydrogens, how many do I have on the left? How many do I have on the right? 1. So, what do we balance first? What comes first? What comes first, everyone? What do we balance first? Correct. Na. We balance the element first. So, in this case, how do I fix up the level of sodium on the left and the right? I add an extra sodium hydroxide on the right. So I put a big 2 out the front of sodium hydroxide. Now I need to fix some things up because when I put this 2, it not only changes the amount of sodium, but it also changes the amount of oxygen and hydrogen. So I need to add 1 more of each over on the right-hand side. Okay. So when we now talk about oxygen, the number of oxygen is 3 on the left and 4 on the right. Okay? What is this going to then change? What are we going to have to change? Which one? Which one will give us 1 more oxygen? The H2O. Good. So we're going to look at that one.